Alright, note I put draft here because I was afraid I was going to have to cut some stuff, and I'm going to have to, so points are going to be rebalanced a little bit so I can easily do math. Alright, number 0, person on the street credit. If you do not know the answer to a problem, mark it IDK, I will give you 20%, but do not leave anything not scratched out, erased, or otherwise there. If you have IDK and some data there, I'm going to grade your data. If it is wrong, you get nothing. Point number 2, my rubric for grading exams is basically the following. If it is correct, it gets 100% of the credit. If it is a calculational mistake, depending on how bad it is, it will cost you up to half the credit on the problem. If it's a really, really minor thing, it may only be a point off or something silly like that. If it's worse, but it's clear you know the concept, you get half credit. If you do not know the concept, you screw up the concept in any way, shape, or form, you get nothing. The reason for this is the difference between known unknowns and unknown unknowns. It is better to know that you don't know something and mark it as such in mission critical and safety critical real world applications. I want you to start owning that. This is your chance to do that. All right. All right, problem number 1, what 2 properties must be true of a correct algorithm? We've studied that to the ground, hopefully you regurgitate it, all right? Number 2, for each definition, give me either the set builder notation or a graphical depiction of the formal definitions for big O, big omega, and big theta. Hopefully you've studied that to the ground and understand it, or can regurgitate it. Number 3, input sizes. Consider the following RAM. It has so many instructions per second. Tell me the exact largest input size that each function below executing on the RAM can process in 8 seconds, assuming the algorithm takes f of n instructions to solve. Be precise. Input sizes are integers. If something does not go to an integer, you have a friend called the floor function. Use it. You may give your answers as either decimals or you may leave them in functional notation. Similar to what you did on the homework. All right? Number 4, bubble sorts back, except slightly modified. You may want to study what that modification is doing. Whoops, my bad. Wrong button. All right. What are the best and worst cases for this version of bubble sort? Not generic bubble sort, this particular one. Give tight asymptotic bounds for each case, meaning thetas. Then, loop invariant for the J-controlled loop. Sketch it. Prove it via initialization, maintenance, term. Same thing for the I loop. Use your J-controlled loop to prove it. If you did your homework, you understood your answer for the homework, this is a very small twist, you're in pretty good shape. If you didn't understand on the homework, practice, practice, practice. Get this one down. Otherwise, if you can't figure it out, these are really good candidates because of that arm-achingly amount of writing you're going to have to do for this. Might be a good candidate for an I don't know. Remember, optimization puzzles. Number 7. First, I give you some recurrence relation or some summation identities that might be helpful. There's your first recurrence. You may either draw me a tree or solve via iterative substitution. You have to do one of those 2 things on this one, whichever you prefer. Show your work for full credit, give me a tight asymptotic bound. If you memorize the asymptotic bound and it's correct, I'll give you half credit. If it is not correct, you get nothing unless you show me some work. If you write, I don't know, 20%. Number 8, another one.
Would master method be allowed in this one?
No.
Awesome.
I was already done.
Yeah, I know, I'm already done.
Yeah, it's into the fourth.
Does it state that above number 7 to use the tree and the...
It says you can either draw a recursion tree or the recurrence relation, then analyze it, or solve the recurrence via iterative substitution. Those are your 2 options.
It doesn't mean that we can't use it to check.
You can absolutely use it to check your work. In which case, you know you better be coming up with this guy somewhere or worse.
Yep.
You know you're in the ballpark. All right?
2 points.
All right. Next ones. Solve each of the following recurrences. No restriction on how you do it. Get it solved. That means iterative substitution's cool. Master method's cool. Trees are cool. If you want to use induction here, cool. If you can magic it out of thin air and it's right, cool. But show your work for full credit in case you screw up.
Wait, so if we have the right answer but no work, you're not You're giving us full credit, is that what you said?
No, show your work for full credit still.
Oh,
I'll give you that credit. Yeah.
It's right there, never mind.
Yeah, still gotta show your work.
Dark magic.
I need to know how you did it. If you can, like, scribble a dark circle of blood on here and, like, show me the invocations you're making and summon a little demon on your paper and show it to me live and the demon whispers the answer, I'll get full credit for that. I'm probably gonna run screaming from the room afterwards, but, I'll give credit for
Thank
it.
you, Mr. Harrison. I'm going to be doing that for ChatGPT.
Yeah.
I'm just going to summon it to my paper.
Yeah, if you can somehow summon ChatGPT on your paper, I'll give you that also.
Just copy paste the exact
Yeah.
response that you get.
In blood, though.
Yeah, in blind.
You're invoking dark magic here, it's got it also.
No number 2 lead. Come on.
Yeah. Alright, string matching. Contrast naive string matching versus the finite state automaton or the Newton-Morse spread algorithm to search for text and pattern matches. What makes this much faster, in other words? Tell me the idea behind it. Alright, then, given pattern of gag and that string right there, define me a finite transducer that encodes pattern P, meaning finite state machine that doesn't have accepting states but recognizes the patterns.
There's a movie reference in there.
Yes, there is. And there's another one on the next one also, because I just watched that movie. And then find the pattern of P, T, find the matches. All right. Number 16, KMP prefix. Note the algorithm's not given here, so memorize the idea behind it. Okay? Then give me the smallest possible palindrome by prepending to it. And show your work. All right. 18 and 19, gimmies, define formal language. That's a memorization definition. That's in the notes. Number 19, why should we care that programming languages are formal languages when implementing algorithms in a given programming language? You just did that. Hopefully you understand from the homework why we care about that. We also just talked about that today. All right. 20, give me a Bacchus-Nauer form of that little guy, which I think we did in the notes. So that one shouldn't be too bad. Number 21, here's a phrase structure grammar that's a little bit nastier, but we talked about it in the context of resolving expressions in both the homework and in the lecture notes. Derive that expression.
Okay.
That's kind of fun.
Yeah. I already did the hard work, now you just gotta show me how to use it.
You gave it to us.
Yeah. All right. 22, briefly describe the distinction between a deterministic and non-deterministic automaton. 23, there is your language, arithmetic. Word is an element of sigma star, where word is a legal arithmetic expression for the following two problems. There are some examples. Diagram a PDA of that guy. We're going to do an in-class exercise of more PDAs to help you probably on Monday before we take the exam. So a little more practice structured in class to give you something to work on. All right. Then number 24, tell me why at least a push-down automaton is required to recognize words in arithmetic. In other words, explain the same thing we did with linear grammars versus right regular and left regular.
The operations in the middle.
And we're stopping there. Because that gets into Turing machines. That's the test. Okay, I heard 12, then 22. And 2. So all the 2 ones, okay. All right, 22. All right, 12.